Okay, everybody. It's Friday afternoon. I thought I would do a few examples of unit conversions. A lot of you guys, I think, expressed an interest in seeing these done out in more detail. So I'm going to do about 6 different examples which show you all the different types of unit conversions we do in class. And the idea here is for you to have something that you can practice on your own. So my recommendation would be to try the problem on your own, and then so kind of hit pause, and then I will go through it, and you can see how what I did compares to what you did, and then that way you can really go through and learn how to do unit conversions. So I'm going to start with the first problem. So this first problem asks for a one-step conversion. It's relatively simple. So it wants us to convert from kilograms to grams. Um, so what we're doing here is we're converting from a non-base unit to a base unit. So remember, grams is the base unit, kilograms is a non-base unit. It's some higher or lower amount of grams than just a single gram. So we know from memorization that 1 kilogram is equal to 1,000 grams. So we'll be using that in this unit conversion. So as always with unit conversions, I start by taking what we have to start with. So we have 50.0 kilograms, and then writing where we need to go, which is grams. So we know that our answer needs to be in grams. And then we can start with our conversion. So what we need to do is we need to set up our first unit conversion. So we're going to take 50.0 kilograms. We're going to set up the unit conversion. And we know that when we set up a unit conversion, the units have to cancel. So kilograms are going to have to go on the bottom so that they cancel, and grams are going to have to go on top. And this makes sense because we need to wind up with grams. So then once you have this all set up, all you have to do is plug in from your memory the ratio, the amount, the relative fractions of kilograms and grams. So what this would be we know for every 1 kilogram there's 1,000 grams. Okay, so then we can plug this into our calculator. So I'm going to show you my calculator and how I do this calculation. So we're going to do everything that's on top. So this is 50 and 1,000. Those are going to get multiplied together. So this is going to be 50 times 1,000. So we're going to get 50,000. The way that you can put this in scientific notation is to just simply count over. So we're going to count 1, 2, 3, 4 decimal places. So we know that our answer, oops, I'm going to have to kind of go over here, is going to be 5.00 times 10 to the 4th. And again, that's just because in scientific notation, this number would be 5 times 10 to the 4th. So the answer here is 5.00 times 10 to the 4th grams. Okay. Now, in terms of Sig Figs, the way that I came up with that is this number right here has 3 significant figures because all the zeros to the right, even those after the decimal point, are significant. So here I have to make sure that my answer has 3 significant figures. Now keep in mind that these conversion factors, unless they're densities, these are going to be absolute values. It just means that there's always 1,000 for every 1 kilogram. It's like, think of it as a dozen eggs. You don't measure a dozen eggs, it's just a dozen. So now we're going to take a little bit more challenging example. So here we have 50 nanometers and we're going to convert it to microns. So in this case, again, we're going to start with what we have. So we have 50 nanometers, and we're going to want to put where we're going. So that's going to be in microns. So what I recommend in these cases where you have to go through multiple conversions is to go through the base unit. And what I mean by that is make your life easy. So you just convert nanometers to meters. And then we're going to convert meters to micrometers. See, this way you only have to memorize the relationships between meters and nanometers and meters and microns. And you don't have to memorize the relationship between nanometers and microns, because that's not an easy thing to memorize. So the way that I would set this up then is we know that for our first conversion we have to have nanometers on the bottom in order for the units to cancel. Okay? And we have to have meters on top. So in my memorization, I remember that there is 1 times 10 to the 9th nanometers for every 1 meter. And then the nanometers will cancel. So now we have our answer in meters. And we want to go to microns so we can set up our next conversion. Meters will have to cancel, so meters are going to go on the bottom. And micrometers will go on top. And I have memorized that for every 1 meter, there is 1 times 10 to the 6th micrometers. So now meters will cancel. And we've converted our answer from 50 nanometers to micrometers based on the conversions. So if we plug this into our calculator, here's how we're going to do this. So we're going to take our calculator. Here's my calculator. Let me shift this up so that we can see. Okay, so we're going to plug this into our calculator. So everything that's on top is going to get multiplied. So we're going to take 50 times 1 times 10 to the 6th. So just to show you, in the calculator, when you have this, microns, the calculator, you need to type in 1E6, okay, the capital E. Just to show you the button on my calculator, it's the EE button. So what that does is that tells the calculator that the E is basically this times 10 to the, and then you just type in the superscript, which will be the 6th. Okay, so everything on top gets multiplied, and then everything on the bottom gets divided. So then I'm going to hit the division sign, and I'm going to plug in my 1 times 10 to the minus times 10 to the 9. Okay, and I am going to get 0.05 as the answer. Now, thinking about significant figures, we have 50 with no decimal point. So if there is no decimal point, then this 0 is not significant. It's only the 5. So this number right here would be the number that we want. Okay? So that just shows you how to do a two-step conversion. Now for the one that I think that you guys have the most problem with. So this is where you have to convert from a volume. So this is a conversions involving volume. But we're converting from meters cubed to a volume in liters or milliliters. Okay, so this is going to involve a couple of different steps, but the main thing is to be able to convert from meters cubed into milliliters. So one thing that I want to refresh everyone's memory on is that 1 milliliter equals 1 cubic centimeter. So this conversion is extremely important, and you're going to keep coming back to this. So whenever you see milliliter, you can just, in your brain, think of that milliliter as also a cubic centimeter. So I think in this case, you can see that what we're really trying to do is convert meters cubed to centimeters cubed. Because if we can get it to centimeters cubed, that answer is really in milliliters, right? So, because we know that for every 1 milliliter cubed, there is 1 centimeter cubed. So let's put in what our numbers are. So 0.0327 meters cubed. Now, so how do we deal with the cubed? I think this is something that's throwing a bunch of people off. So to deal with the cubed, we have to first set up the conversion as though there was no powers. So what I do is I take this equation, and I know that I want to go from meters to centimeters. So that's how I set it up. So I put meters and I put centimeters. And again, I'm just going to simply plug in the information that I memorized. So I know there's 100 centimeters for every 1 meter. Now here's how we deal with the cubed. If we take this entire conversion and we bring it to the cubed power, then what we wind up having is 100 centimeters cubed. So 100 cubed centimeters cubed over 1 cubed times meters cubed, right? If you put that cubed in and sort of quote-unquote distribute it into everything, then what you wind up with is centimeters cubed over meters cubed. So all you have to do is cube this 100 centimeters and cube this 1 meter. So 1 meter cubed is just going to be 1 meter. 1 meter is cubed is going to be equal to 1 cubic meter. So basically how this is going to look like in the calculator is as follows. So what we're going to do is we're going to take our 0.0327. Okay, now we have to cube 100 centimeters. So if you take 100, oh, I'm sorry, we're going to multiply this. Remember, anything on top we multiply. So all we have to do is multiply by 100 cubed. So to cube, you're going to hit the little up arrow on your calculator and then hit to the third. So now what this is doing basically is we're cubing this entire ratio. So we're taking 100 cubed and we're cubing the unit. So this is now going to be the ratio for 100 cubic centimeter for 100 cubed centimeters over 1 meter cubed. So if we hit enter here, that's going to be 3.27 times 10 to the 1, 2, 3, 4 times 10 to the 4th cubic centimeters. Okay. So that's how you do that. So it's very straightforward. So you can do this for things like squares. So if you needed to square the units, you could just simply square the conversion. All you have to do is just, if you need to convert meters cubed to another unit, just cube both the top and the bottom. And in a lot of cases, because one of the two will be a 1, you don't even have to do anything because 1 cubed is just 1. So all you're doing is just cubing the value here, and then you should get the right answer. So in this case, we get 3.27 times 10 to the 4th cubic centimeters. And then we're going to multiply this by the fact that 1 centimeter cubed is equal to 1 milliliter. So we don't even do anything. We just get 3.27 times 10 to the 4th milliliters. Okay, this one's very important. So if anybody doesn't understand this one still, come and talk to me because I can show you a couple of other examples. Okay, so what's next up on the list? So here, now we're going to get some ones with density. So this is a one-step conversion with density, a very simple density conversion. So for this one, it asks for us to compute the volume in milliliters for a 23.2 gram sample of some metal if the density is 1.92 grams per mil. So the way to think about density is, in unit conversion, is just that 1.92 grams is going to equal 1 mil. Okay? So it's the same thing for kilograms and grams. So we know that for every 1 kilogram, there is equal to 1,000 grams. So this can be put into a unit conversion just like this. So density is very powerful because it just is another tool in our toolkit when we're doing unit conversions. So I'm going to set this up the same. So for the density, I'm not even going to do density equals mass over volume because I don't need, density is equal to mass over volume. I don't even need this equation to do this calculation. You can do it with this equation, but I find that doing this as a unit conversion makes life a lot easier. And if you understand it in terms of unit conversions, you'll be able to combine density with any other conversion that you have. So if you can understand how to do this as a unit conversion, that'll be a very powerful tool in your toolkit. Okay, so for this one, it asks us to do 23.2 grams. Okay, so we're going to start with 23.2 grams. And it wants us to have our answer in mils. So we're going to put our answer over here in mils. So for this one, again, we can use this relationship to come up with a unit conversion. So we need our answer. Oops, let me write this so that's a little bit easier for you to see. So mils. So in this case, we know that the relationship is 1.92 grams for every 1 mil. So we can set this up like a standard unit conversion. We're going to put grams on the bottom because that unit has to cancel. And then we're going to put the 1.9, the mils on top, So now we have our unit that we want to be in on top. So grams will cancel. And then we just fill it in. So we know that there's 1.92 grams for every 1 mil. So in this case, again, we can go to our calculator. And because we have a 1 on top, we're not going to multiply by anything, so that would be 23.2 times 1 are the same. So in this case, all we're going to do is divide 23.2 by the 1.92. So in this case, I get 12.08 mils. Now, if we consider Sig Figs, there's going to be 3 Sig Figs here, so we need 3 Sig Figs here, so I'll mark that. And then our final answer will be 12.1 mils, because we round up from the 0.08. Okay, so that's just to show you a simple conversion with density, and now we can build on that conversion if we have things that are not in standard base units. So if we take a look at the next problem, this one asks us for a multi-step conversion using density. So here it says calculate the mass in kilograms. So already I know that my units are not going to be in base units. I'm going to have to convert to kilograms. So calculate the mass in kilograms of 0.02505 liters of ethanol if the density is 0.786 grams per centimeter cubed. Okay. So one thing that I want to point out right off the bat is we're dealing with liters here. So this density is already going to cause us some problems because this density is in centimeters cubed. But not to worry, because 0.786 grams per centimeter cubed is going to equal, since we know that for every 1 centimeter cubed there's 1 mil, this is going to be equivalent to 0.86 grams per milliliter. So anytime you see grams per centimeter cubed, you can just go ahead and substitute in milliliters and vice versa. So no matter what they give you the density in, if the density is in centimeter cubes, you can make it milliliters and vice versa because it's a one-to-one relationship. Okay, so we're going to start here with our volume. So that's going to be 0.0205 liters. And then we can go ahead and start doing our conversions. Now, unfortunately, in this case, we're starting with liters, but our density is in milliliters. So in order to make it work with this unit conversion, we have to get this liters into milliliters. So we're going to use our knowledge of the standard system of measures. And we know that by memorizing, oh, and again, I always write my answer. We know that we need to have the mass in kilograms. Okay, so that should go over there. So, like I was saying, with the liters, we have to get this into milliliters. So we're going to put liters on the bottom because that will cancel, and then we'll put milliliters on top. And we know the relationship here is that for every 1 liter, there's 1,000 milliliters. And now at this point, we are good to go to use the density. So we know that we can convert now from volume to mass using the density. So let's go ahead and set up that unit conversion. So now we're like up here. We can use this direct conversion. So in this case, instead of going from mass to volume, we're going from volume to mass. So we have to put milliliters on the bottom and grams on top, and we just fill it in. So we know that for every 1 mil, there is 0.786 grams. Okay. Mils will cancel, and now we have our answer in grams. But we're not done yet. We have to get our final answer in kilograms. So in order to get to kilograms, we have to convert grams to kilograms. So to do that, we're going to set up a unit conversion. And what we're going to do is we're going to put grams on the bottom and kilograms on top. So now I've memorized that there's 1,000 grams for every 1 kilogram. And we're all set. So grams will cancel, and now we're in kilograms. Okay, so now, this is very important about plugging these things into your calculator. So watch how I do this. Everything that's on top gets multiplied, and then anything that's on the bottom gets divided. So let's just go ahead and set this up. So we're going to say 0.0205. Then we're going to multiply by 1,000. And then we're going to hit the multiplication button again because we're going to multiply by 0.786. And then we're going to, for anything on the bottom, you hit the divide button. So in this case, we're going to divide by 1,000. So we hit the divide button and then we type in 1,000. Okay, so we hit enter. So in this case, I get an answer that is 0.016113, but we have to look at our Sig Figs. So here we have 3 Sig Figs in the answer, in the starting value. We have 3 Sig Figs in our density. So our final answer is going to be 0.0161 kilograms. Okay. All right, so now the last one is probably one of the more difficult unit conversions because it combines some stuff. Like I say, this has some added flair, so this might be a good style of question for the exam. Might not find the exact same one, but the exam. Okay, so this one asks for calculate the mass of a cube with an edge length of 3.2 centimeters if the density of the material is 1.23 grams per mil. Okay, so in this case, they give us an edge length of a cube, but they don't give us volume or mass. So we have to go and figure out now what the volume or the mass is. So in this case, it's asking us to calculate mass. So we know that at the very end, oops, I should have put here in this case. So let's calculate the mass then. So if it just says, if it's vague like this, you can calculate the mass however you want. So we'll make our lives easier and just compute it in grams because that's perfectly fine for a mass. So, but the question though is how do we deal with this edge length of 3.2 centimeters? And remember, volume you can calculate volume for any three-dimensional object. So, for example, cubes, if we draw one out here, an edge length of a cube, so a cube has 6 different squares, so we're saying this is 3.2 centimeters. So for a given cube, the volume of that cube is going to equal the length times the width times the height. And in this case, since the length, width, and height are all the same, a cube has all the same edge lengths, that is just going to be, the volume is going to equal 3.2 centimeters times 3.2 centimeters times 3.2 centimeters, okay? Or you could think of this also as 3.2 centimeters cubed. So if I bring the calculator in here, I'm just going to do that, 3.2 times 3.2 times 3.2. So I get a volume equal to 32 point, we'll say, I should say, we're getting a volume of 32.768. So I'm going to put down 7 and put my little Sig Fig marker here. Oops, I'm sorry. We actually only have 2 Sig Figs. So I'm not going to put my Sig Fig marker here. I'm going to put my Sig Fig marker there. So I know that this is where I have to truncate to in the end. I only have 2 Sig Figs. And then the rest, this is just so that we don't round it off just yet. So I have 2 Sig Figs to work with. Okay, and the units here are going to be centimeters times centimeters times centimeters, so the units are centimeters cubed. So this should look very good, because this is something we need in order to calculate density. So again, we can say that if this is 1.23 grams per mil, because for every 1 mil there's 1 cubic centimeter, we can also write this as 1.23 centimeters cubed. I'm sorry, 1.23 grams per centimeters cubed. There we go. So we can always swap out this mils and this cubic centimeters. So now let's go ahead and just do the problem. So we have centimeters cubed, we have grams per centimeter cubed, and we're in business, so we can do the direct calculation. So 32.77. Again, I put my Sig Fig marker there, centimeters cubed. We use our density as a relationship, so this one will be 1.23. I'm sorry, so we set this up. We know we need to have grams. So on the bottom, we're going to put centimeters cubed because we need to get rid of those. And on the top, we're going to put grams. And then we just plug it in. So 1.23, I'm sorry, for every 1 centimeter cubed, there's 1.23 grams. So now we can just plug this into our calculator. So if I bring the calculator over, you know what, let me just back out a little bit so you guys can. Okay. Oop, I guess the little unit thing there is off. So what we're going to do is just a simple multiplication. We can multiply 32.77 times 1.23, and our answer is going to be 40.31 grams. But remember, we only have 2 Sig Figs, so this 40.31 grams is really going to be 40 grams. So that indicates that there's 2 Sig Figs. So by putting the explicit decimal point here, I'm indicating that the 0 here is significant. This could also be written as 4. This could also be written as 4.0 times 10 to the first, and that would be grams. So again, that indicates that there are 2 Sig Figs. Okay, so one other thing, I'm just going to flip the paper over and show you real quick. Okay, so let's say that you wanted to convert from something like 3 millimeters squared to kilometers squared. Okay, so this would be converting an area. So remember, if you have length times width, that's an area, to kilometers squared. Why you would want to do this, who knows? But the idea, though, is that this is how you handle multiple conversions with these squared units or calculated units. Okay, so we start with 3 millimeters squared. And again, we're going from a non-base unit millimeters to a non-base unit kilometers. So here, this will be a good example of how we deal with these squares where we have two conversions. So we'll go again. So again, what we'll do here is we'll go through the meter. So at first, I will say that we need to convert from millimeters to meters. So on the bottom, I'm going to put millimeters, and on the top, I'm going to put meters. And I've memorized that for every 1 meter, there's 1,000 millimeters. Now, in order to get these units to match, I have to square the top and the bottom. So I'm going to square this thing, this unit conversion. So that's going to give me 1 meter squared on top, and then I have to square 1,000, and I have to square the unit. So when I type this into my calculator, I'll make sure that I type in 1,000 squared. So that's going to get us to meters squared by squaring that unit. Now, in order to do the second part of the conversion, we can go from meters to kilometers. So we know that we know that we need to get units to cancel. So we're going to put meters on the bottom. We're going to put kilometers on top. So for every 1 meter, for every 1 kilometer, there are 1,000 meters. And again, in order to make the units match, we have meters squared here. We're going to have to square this entire conversion. So again, 1 squared is 1. So we have 1 kilometer squared is going to be equivalent to 1,000 squared meters squared. Okay. So we just plug the exponents in. So now let me show you how to plug this into your calculator so that you get the right answer. Now everything on top gets multiplied, but we don't have to do anything with that. Oh, and again, I'm sorry. So millimeters are going to cancel. Meters squared are going to cancel, so that's going to give us our answer in kilometers squared. So everything on top gets multiplied, but in this case, the numbers are on top are just 1, so we don't have to do anything there. So here's how we handle the bottom. So we're going to take 3, and for everything that's on the bottom, we're going to hit the division side. So we're going to hit the 3 divided by 1,000, hit the up caret, squared, and then we're going to divide by 1,000 squared. Okay, so that is going to give us a value of 3 times 10 to the minus 12 kilometers squared. Okay, now let me show you why we're hitting the divide button, because here's really what's happening. By hitting the divide button, what you're doing is you're putting these two 1,000s below below. So if you think about it, the way that we're doing this is we really have 1 meter squared times 1 kilometer squared divided by 1,000 squared millimeters squared times 1,000 squared meters squared. Okay? So in order for all of this to happen, we can either divide by both of these numbers, or we can use the parenthesis. So another option for doing this would be to do the following. So instead of hitting divide and then divide again, we can take 3, divide by parenthesis, and now we can write it like this. So we can write 1,000 squared times 1,000 squared, close parenthesis, and now what this is going to do is this is going to do order of operations. So this is going to do 1,000 squared times 1,000 squared first, and then it's going to take 3 and divide by that number. So when we plug this in, we get the same number. You will not get the right number if you do the following. So if you type in the following, if you type in 3 divided by 1,000 squared, and then you think, oh, well, it's 1,000 squared times 1,000 squared, so let me just multiply by 1,000 squared. You don't get the right answer. And the reason for that is because order of operations. So here, this is putting both of these on the bottom. This is also putting both of these on the bottom. By doing 2 separate divisions, you put them both on the bottom. So it's your choice of how you want to do it. If you do it this way, where you try to take the first one and divide it, and then you try to take the second one and multiply it, the calculator is not going to get that right. So make sure you do it either this way or this way in order to get the right answer. Okay, so I think this covers unit conversions. Please go through this worksheet and try to please go through this worksheet and try to do it on your own before you look at the answers. And then if you have any questions, let me know. We can go over this either before or after class. Okay, thank you very much and have a great weekend.